Final review, part 2. Number 27. Find the derivative of f of x equal x to the third power times square root of quantity 4x plus 6. We can see this function is a product of two functions. So to take the derivative of this function, we're going to have to use product rule. And while you're using product rule, square root of 4x plus 6 is composition of two functions. So we are going to need to use a chain rule on the part when we're taking derivative of a second function. So let's do that. So my f prime of x equal, take the derivative of a first function, I get 3x squared times second function, plus, now use the first function the way it is and take the derivative of a second function. And second function is 4x plus 6 to the 1/2 power. So when you take the derivative of that, I have 1/2 times 4x plus 6 to the lose 1 power. You get negative 1/2 power times derivative of inner function is just 4. Then 2 and 4 cancel and this become 2. And now to simplify that, I do see I have a common factor x squared and x squared. So we're going to take the x squared out. And with the 4x plus 6 to the 1/2 power and 4x plus 6 to the negative 1/2 power, we factor out the lower power. So you're going to have to take it out the x squared and 4x plus 6 to the negative 1/2 power. Then you can see from the fourth term, all you have left is 3 times. In order to get 1/2 power, you would need to have a 4x plus 6 to the power 1, since negative 1/2 power plus power 1 gives you 1/2 power. And from the second, remember you had this 2, and because you took the x squared out, you still have an x there. So it is plus 2x. So then let's simplify what's inside of a bracket. 3 times 4x is 12x plus 3 times 6 is 18 plus 2x. Combine like terms, I get 14x plus 18. So now, when you simplify that, I have x squared, I have 14x plus 18 over 4x plus 6 to the negative 1/2 power needs to go to the denominator, and it is now positive 1/2 power, and since 1/2 power is a square root, it is a square root of 4x plus 6. And I don't see any answer like that from my multiple choice, and you can see inside of a parenthesis, you have a common factor 2. So let's take it out the 2 also. So you have a 2x squared, 7x plus 9 over square root of 4x plus 6. So the answer is B. Number 28. Find the derivative of g of x equal quantity x minus 2 to the 4th power over 5x cubed. So what do we need to use to take the derivative of g of x? Quotient rule. Correct. And what was the quotient rule? Low d high minus high d low over square below. So let's do that. So g prime of x is equal to low 5x cubed d high, derivative of high, that's a composition of a function. So you need to use a chain rule. So you need to take the derivative of outer function, which is power function. So you get 4 times x minus 2 to the 3rd power times derivative of inner function is 1. So I have a low d high now, minus high. High is x minus 2 to the power 4 times d low. Derivative of low is 3 times 5, which is 15x to the 2nd power over square below, which is equal to, well, times 1 doesn't do anything. 5 times 4 is 20. So I have a 20x cubed times x minus 2 to the third power minus 15x squared times x minus 2 to the power 4 over, when I square it, I get 25x to the 6th power equal to, let's see the common factor. Between 20 and 15, common factor is 5. Between x cubed and x squared, common factor is x squared. X minus 2 to the third power and x minus 2 to the fourth power, common factor is x minus 2 to the third power. Open the bracket. Then from the fourth term, 5 times 4 is 20. X squared times x is x to the third power. And all x minus 2 to the third is out. Minus 5 times 3 is 15. X squared is all out. X minus 2 to the third times x minus 2 is x minus 2 to the fourth over 25x to the 6th. So when you clean inside of a bracket, I get 4x minus 3x plus 6, which is equal to x plus 6. So that's what I get when I clean it up the bracket. So I'm gonna get 5x squared, x minus 2 to the third power times x plus 6 over 25x to the 6. But then 5 should cancel, and I will still have a 5 there. X squared cancel, and I will have a x to the power 4. So the final answer is x minus 2 to the third power times x plus 6 over 5 x to the power 4. So the answer is E. Number 29. Find the equation of the line tangent to f of x equal quantity 2 minus cosine x to the third power at the point 0, 1. So to find the equation of a line, we need a slope and a point. And you do have a point already, and all I need is a slope here. And I do need a slope at x equal 0. So what I need to find is slope, which is f prime of 0. And once you have that, you can use a point slope form of a line, and you can find the equation of a line. All right, so let's find the f prime of x. F prime of x equal, and since you have a function raised to the third power, you need to use chain rule. So derivative would be 3 times inner function raised to the second power times derivative of inner function. Derivative of 2 is 0 minus derivative of cosine x is negative sine x. So this is equal to 3 sine x times 2 minus cosine x squared. So I found my f prime of x. So my slope is f prime of 0, since it's at 0, 1, and that will be 3 sine of 0 times 2 minus cosine of 0 square, which is equal to 3 times sine of 0 is 0, and cosine of 0 is 1. So you have a 2 minus 1 to the second power, but doesn't matter, right? We're going to multiply everything by 0, so you get 0. So slope of a tangent line is 0. So you have line that is a slope 0, which is horizontal line. And since this horizontal line passed through 0, 1, your equation of a tangent line is y equal 1. So the answer is A. Number 30. Find the slope of the line tangent to f of x equal cotangent 5x at the point pi over 4, negative 1. So this time, they just said to find the slope only, which is f prime of at what point? Pi over 4. So that's all I need to find out. So let's find f prime of x. And since my function is cotangent of 5x, since it's not cotangent x, this is again composition of a function, and you need to use chain rule here. Derivative of cotangent is negative cosecant square of inner function times, now derivative of inner function is 5. So it is negative 5 cosecant square 5x. So f prime of pi over 4 is negative. This is really equal to negative 5 times cosecant 5 times pi over 4 for x, whole thing squared. That's what cosecant square 5x is, right? So this is equal to negative 5 times cosecant of 5 pi over 4. Cosecant of 5 pi over 4 is negative radical 2. So when you square it, you get negative 5 times 2, which is negative 10. You just found the slope, and slope is negative 10, which is C. Number 31. Find second derivative of sine 4x to the third power. So to do that, we're going to find the first derivative of sine 4x cubed first. So let's find f prime of x. F prime of x is equal to, what do we have? I got sine 4x to the third power. So this is composition of functions, which we need chain rule. So let's take the derivative of outer function, and derivative of outer function is cosine. Inner function don't change, so it is cosine 4x to the third power times, now we multiply by derivative of inner function, which is 12x squared. So my f prime of x is 12x squared cosine of 4x cubed. So now, to take the second derivative, we need to use product rule, since it's a product of two functions. So take the derivative of 12x squared, you get 24x times cosine of 4x cubed plus 12x squared times derivative of cosine of 4x cubed, and derivative of cosine is negative sine 4x cubed times chain rule 12x squared. You can see that 24 is a common factor. So let's take it out, 24. And also x is a common factor. Since your second term has x squared and an x squared, that's x to the fourth. So you do both have an x there. And that's all you have as a common factor. Since 24x is out, what you have from the first term is cosine 4x cubed. Since you have a minus factor there, it is minus. And you took the 12 out and a 2 out, so this is a 6. So you have a 6. You took an x out, so you have an x times x squared, which is x to the third power sine 4x cubed. So I think we simplified as much as we can, and you can find the answer now, and answer is D. Number 32. Find f of x equal 2 times square root of x minus 3. Find triple prime of x. So let's first rewrite f of x as f of x equal 2 times x minus 3 to the 1/2 power. Okay. So your first derivative, f prime of x, is equal to 1/2 times 2 times x minus 3 to the negative half power, right? So then 2's get canceled. So all you have is x minus 3 to the negative 1/2 power. I'm not going to simplify this since this is not the answer we're looking for. So now let's find the second derivative. Second derivative of f is negative 1/2 times x minus 3 to the, when you subtract 1 power, you get negative 3 over 2 power. And you need to multiply by derivative of inner function, but it is just 1. So that's all you get. It is negative 1/2 x minus 3 to the negative 3/2 power. Okay, so now let's find f triple prime of x. F triple prime of x is equal to, you need to bring this down, so negative 3 over 2 times, you had a negative 1/2 times x minus 3 to the, lose 1 power from negative 3/2, you get negative 5 over 2 times derivative of inner function is just 1. So again, when you simplify this, negative 3 over 2 times negative 1/2 is positive 3 over 4. And because x minus 3 to the negative 5 over second power is negative exponent, when you bring it to the bottom, you get x minus 3 to the positive 5 over second power. And if you look for the answer is B. Number 33. Using implicit differentiation, find dy dx for x squared y plus y squared x equal negative 2. So we are going to take the derivative of both sides with respect to x. D dx of x squared y plus y squared x equal d dx of negative 2. So we take the derivative of both sides with respect to x. So with respect to x squared y, we need to use product rule. And x squared, it is regular differentiation. So you just get 2x times y plus x squared times derivative of y is 1 times chain rule dy dx. Plus, now we're going to take the derivative of y squared x. So take the derivative of y squared. We get 2y dy dx times x plus y squared times derivative of x is just 1, which is equal to derivative of constant is 0. Your next step was then you collect any dy dx term on one side and send every term that does not have dy dx to the other hand side. So I have x squared dy dx plus 2xy dy dx equal to negative 2xy minus y squared. Now, next step was to factor out the dy dx. So we're going to take it out the dy dx. I get then x squared plus 2xy inside of a bracket is equal to negative 2xy minus y squared. Your last step is divide both sides by term next to dy dx. So we divide both sides by x squared plus 2xy, x squared plus 2xy. And my dy dx is what I have on the right-hand side of equation above. However, I don't see that in the answer. So we're going to factor out negative 1 from the numerator and put it in the front of a fraction bar. So you will have y squared plus 2xy over x squared plus 2xy. So your answer is A. Number 34. Using implicit differentiation, find the dy dx for 4 cosine x sine y equal y minus x. So do the same thing again. We take the derivative both sides with respect to x. So we have a d dx of 4 cosine x times sine y equal d dx of y minus x. And your left-hand side, 4 cosine x times sine y is product. So again, we're going to use product rule. So derivative of cosine x is negative sine x. So I get negative 4 sine x times sine y plus, now we're going to take the derivative of second function. And derivative of sine y is cosine y dy dx. So I'm going to get 4 cosine x, take the derivative of sine y, we said cosine y dy dx equals derivative of y is 1 dy dx minus derivative of x is 1. So now we're going to collect the dy dx term on the left. So I'm going to bring this guy over, and any terms that do not have dy dx, we're gonna collect on the right hand side. So I'm going to send this one to the right hand side. So then I will have 4 cosine x cosine y dy dx minus dy dx is equal to 4 sine x sine y minus 1. Now your next step is to factor out dy dx. Then you get 4 cosine x cosine y minus 1 equal 4 sine x sine y minus 1. And your last step is to divide both sides by term next to dy dx, which is 4 cosine x cosine y minus 1 both sides. So your dy dx is equal to what you have on your right hand side above equation, 4 sine x sine y minus 1 over 4 cosine x cosine y minus 1. So the answer is D. Number 35. Using implicit differentiation, find d square y over dx squared for x squared minus y cubed equal 9. So let's first find dy dx. So to do the implicit differentiation, we take the derivative with respect to x both sides. So d dx of x squared minus y cubed equal d dx of 9. So when you take the derivative of x squared with respect to x, it is just 2x minus derivative of y cubed with respect to x. We need to use chain rule. So we get 3y squared dy dx equals d dx of 9 is just 0. And I only have one term that containing dy dx. So we're gonna just send that term to the right hand side to avoid the negative. So I have now 2x equal 3y squared dy dx. Now to solve for dy dx, of course, we're going to divide both sides by 3y squared. So we found your dy dx, and dy dx is equal to 2x over 3y squared. Now we want to find the second derivative, and to do that, we need to use quotient rule. Since our dy dx is quotient, so we are going to take another derivative of dy dx, both sides respect to x. Then I get derivative of 2x over 3y squared. I use quotient rule. Low 3y squared d high, derivative of 2x is 2 minus high 2x times d low, derivative of 3y squared with respect to x will be 6y times dy dx over square below. So I need to square 3y squared. When I simplify, I get 6y squared minus 12xy dy dx over 3y squared, you square each term, I get 9y to the 4th power. So then you need to replace dy dx by what the dy dx you found earlier, so that your d squared y over dx squared would only contain xy expression. So I'm going to do that. So I have a 6y squared minus 12xy, and my dy dx I found earlier was 2x over 3y squared over 9y to the 4th power. So then when you simplify, I get 6y squared, and 3 and 12 cancel, and y, one of them get canceled. So what I have is minus 4 times 2 is 8. X times x is x squared over, I still have 1y in the denominator over 9y to the fourth power. Now, my answer is a complex fraction, and as you see from your multiple choice, I don't have any complex fraction answer. So I need to simplify that. And to do that, you would need to multiply your top and bottom of a fraction by y. So we're going to multiply by quantity 1, which is the y over y. And you're going to have to distribute the y from the top. And when you multiply 6y squared times y, you get 6y to the third power. And when you distribute second time, y's get canceled. You get minus 8x squared. In the bottom, when you multiply these two, you get 9y to the fifth power. And that would be your d squared y over dx squared. And I don't see that from your multiple choice, so you need to factor out the 2 from the numerator. And if you do, you get 3y cubed minus 4x squared over 9y to the fifth. The answer is B. Number 36. The area of a circle is increasing at the rate of 8 pi square centimeter per second. So this is related rates. Remember how to do this? Okay, so area is increasing at the rate of 8 pi square centimeter per second. So what's given is rate of change of area with respect to time t. And they said it is increasing, so it must be positive. And it is 8 pi square centimeter per second. And what they want you to find is how fast is the radius of a circle increasing. At the instant, the radius is 6 centimeter. So they're asking you to get how fast radius of a circle increasing. So they want you to find rate of change of radius with respect to t, which is dr dt, at instant when r is equal to 6 centimeter. So to do that, I need to find out a formula that relates area of a circle and the radius. And of course, you do know that. That's a very famous formula, which is area of a circle equal pi r squared. And then you need to do the implicit differentiation. So we are going to take the derivative of both sides with respect to time t, pi r squared. Then derivative of a respect to t is 1 dA dt. And derivative of a pi r squared with respect to t is 2 pi r dr dt. And because we're trying to get dr dt right now, we want to divide both sides by 2 pi r. So then you will get dr dt equal dA dt divided by 2 pi r. So now I want dr dt when r equals 6 centimeter. So plug everything you know. dA dt was given. It is 8 pi square centimeter per second over 2 pi. Radius is 6 centimeter. So then 2 and 8 cancel and you get 4. 4 and 6 cancel also, so 4 becomes 2, 6 becomes 3, pi's get canceled, so the answer is 2/3 centimeter per second. And the answer would be C. Number 37. The radius of a spherical balloon is increasing at the rate of 2 inches per minute. How fast is the volume of the balloon increasing at the instant the radius is 5 inches? And the volume formula is 4/3 pi r cubed. Alright, so what's given is what? You know the radius is increasing at a rate of 2 inches per minute. So what's given is dr dt, the rate of change of a radius respect to time t, which is equal to, since it's increasing, it's a positive number, and it is 2 inches per minute. And it's asking you to find how fast the volume of the balloon increasing. So they want to know the rate of change of a volume with respect to time t. So I have to find dv dt, the rate of change of a volume with respect to time t at what instant? When radius is 5 inches, when r equal 5 inches. So that's what I have to get. And to do that, we're going to use this formula and do the implicit differentiation both sides. So let's take the derivative with respect to time t of v equal derivative with respect to time t of 4/3 pi r cube. So when you do so, derivative of a v respect to t is 1 dv dt equal 4/3 pi r cube. When you take the derivative with respect to time t, 3 comes down, 3 cancel, so you get 4 pi r square dr dt. And because they wanted you to find the dv dt, we can use the equation the way it is, and let's plug in number. dv dt when radius equal 5 inches is equal to 4 pi times radius 5 inches square times dr dt was 2 inch per minute. So when you multiply them all, you get 200 pi inch cube per minute. So answer is E. Number 38. A 10-meter long ladder is being pulled up the side of the building by a rope traveling at 0.5 meter per second. How fast is the end of the ladder traveling along the ground at the instant the end is 6 meters from the wall? So you can see from this picture, this ladder is being pulled up. So what's going to happen is, if you call this a horizontal distance from the building to the ladder, call x, and if you call vertical distance of this ladder from ground to the side of the wall, y, you can see y will be increasing since the ladder is being pulled up. X will be decreasing because it is going towards the building. Okay? And what's given is this y is going up at 0.5 meter per second. So what's given is dy dt, which is, since the y is increasing, it's a positive 0.5 meter per second. And it's asking how fast is the end of ladder traveling along the ground. So they are asking dx dt at the moment when the instant the end is 6 meters from the wall, when x equal 6 meters. All right, this time they did not give us any equation, but you can see the ground and the building will make 90-degree angle, and that won't change even if you're pulling the ladder up. You will always have a right triangle. So this x and y and 10-meter ladder will always make a right triangle. Therefore, you can use Pythagorean theorem. And Pythagorean theorem says what? A leg square plus leg square equal hypotenuse square. So you got x squared plus y squared equal 100. And now, of course, we're going to take the derivative with respect to t both sides. So when you do so, let's take the derivative both sides with respect to t. So then you have 2x dx dt plus 2y dy dt equal derivative of 100 is 0. So then, because you're looking for dx dt, I'm going to send the 2y dy dt to the other hand side. So I have 2x dx dt equal negative 2y dy dt. And then I'm going to divide both sides by 2x. Then dx dt is equal to 2's get canceled, so you have a negative y over x dy dt. And now you can evaluate at x equals 6. So dx dt at x equals 6 is negative x equals 6. dy dt was given, it was 0.5. Oh, I don't have a y though, right? So what do? You need to go back in original equation of x and y. X and y are always related to each other by x squared plus y squared equal 10 squared, which is 100. And when x equals 6, you can plug x equals 6 so that you can find out what the y has to be. So that will say 36 plus y squared equal 100. And y squared then is equal to 64. So y is equal to 8 since it's got to be positive. So y has to be 8 here. And therefore, when you simplify it, you get negative 2/3. And why is it negative 2/3? Because x is decreasing. So x is decreasing at negative 2/3 meter per second. So the answer is B. Number 39. A balloon is rising at a rate of 6 feet per second from a launching point on the ground. An observer located on the ground 5 feet away from the balloon's launching point measures the angle of elevation to the balloon. At what rate is angle of elevation changing? So that will be d theta dt. At the instant the balloon is 12 feet above the ground. That's what we have to find. And what was given at the beginning? The balloon is rising at the rate of 6 feet per second. So dh dt is given. And because it is increasing, it is a positive number, and it is 6 feet per second. All right, and I have to find d theta dt. So what is the good equation that would include the theta and the h, and knowing the distance is a fixed number 5? Yes, that will be tangent theta, since you have adjacent and the opposite and the theta. So equation that you want to use is TOA. Tangent theta is equal to opposite, which is h, over adjacent, which is 5. So this is the equation you want to use. And you are going to take the derivative with respect to t both sides. So if you do that, d dt of tangent theta has to be equal to d dt of h over 5. So derivative of tangent theta is secant squared theta d theta dt, which is equal to, let's look at that as 1/5 times the h. So derivative of that will be 1/5 times dh dt. And because we are trying to get d theta dt right now, you can divide both sides by secant square. So I'm going to divide by secant square theta and multiply your right hand side by 1 over secant square theta so that we avoid a complex fraction. Then d theta dt is, what's 1 over secant square? That will be cosine square. So you have 1/5 times dh dt times cosine square theta. And now we need to do a little bit of work here because we have to get cosine square theta at the moment when h equals 6 feet, right? So to get the answer d theta dt at instant h equal 12 feet equal to 1/5 times dh dt was given, and it is 6 feet per second. And to find the cosine theta, I need to find the length of hypotenuse when h equals 12. So from the right triangle we have, so let's get the length of hypotenuse. So this is a 5, and this is instant when height is 12. So my hypotenuse is square root of 5 squared plus 12 squared, which is equal to square root of 25 plus 144, which is equal to square root of 169. So it will be 13. So cosine theta then is ka, this is where the theta was. So adjacent over hypotenuse. So it's a 5 over 13. So cosine square theta will be 5 over 13 square. So when you simplify that, you will get 30 over 169. We're looking at the real number now. So obviously, we're dealing with real numbers. So radian per second. So the answer is D. Number 40. Locate the absolute extrema of f of x equal 3x to the 2/3 power minus 2x on the closed interval -1 to 1. So do you recall how to locate the absolute extrema? We learned that if f is continuous on the closed interval a to b, then by extreme value theorem, both the maximum and minimum exist. This is a cube root function minus 2x. Because cube root function is continuous on all real numbers and 2x function is continuous on all real numbers, cube root minus 2x will be continuous on all real numbers, so it will be continuous on -1 to 1. So both absolute max and absolute minimum exist by EVT. How to get that? We first find the derivative, find the critical numbers, because relative max and relative minimum only happens on the critical numbers. So we're gonna find all relative extrema and the point function value, pick the highest one for absolute max, pick the lowest one for the absolute minimum. Okay, let's do it. So first, we need to find the critical number. So f prime of x equal 2/3 times 3x to the lose 1 power, I get -1/3 power minus derivative of 2x is 2. Then 3's get canceled. What I have is 2 over x to the -1/3 power go to the denominator. It is now x to the +1/3 power, which is cube root of x minus 2. Let's have a common denominator. So multiply by cube root of x, top and bottom of the fraction. So I have 2 minus 2 cube root of x over cube root of x. So is this undefined sometimes? Yes, my f prime does not exist when x equals 0. But f of 0 exists. So since f of 0 exists and f prime of 0 does not exist, 0 is a critical number. And when is this f prime of x equals 0? My f prime of x equals 0 if numerator is 0. Numerator is 0 if cube root of x is equal to 1. That would imply x equal 1. So my f prime is 0 when x is equal 1. So therefore, I have a two critical number, x equal 1 and x equal 0. But you can see one of my critical number happened to be my endpoint too. So all I have to do now is find the three function values. So then f of 0 is equal to, you gotta plug it into original function, 3 times cube root of 0 square minus 2 times 0, which is 0 times 3, which is 0 minus 0. So it is 0. And f of 1, my another critical number, and at the same time, one of the endpoint is 3 times cube root of 1 square minus 2 times 1, which is equal to 3 subtract 2, which is 1. F of -1 is 3 times cube root of -1 square minus 2 times -1. So I get 3 plus 2, which is 5. Absolute maximum is largest of the three, which is a 5. And smallest out of 3 is 0. So this is your min. So your answer is C. Number 41. Locate the absolute extrema of f of x equal x cubed minus 12x on the interval 0 to 4. Since f of x is a polynomial, it is continuous on all real numbers, so it is continuous on closed interval 0 to 4. So you will be guaranteed to have both absolute max and absolute min by EVT. Let's find the critical number. So f prime of x is equal to 3x squared minus 12, and this will be never undefined, and it is 0 when 3x squared minus 12 equals 0. Factor out 3, x squared minus 4 is 0. This factors more as 3x plus 2 times x minus 2 equals 0. So your f prime of x is 0 when x is equal to or negative 2, and you found your two critical numbers. However, negative 2 is not in the interval 0 to 4, so you can disregard. And now you need to find the f of 0, f of 2, f of 4. So let's find the function values at critical number and at the endpoint. So f of 2 critical number is 2 cubed minus 12 times 2, which is 8 minus 24, which is negative 16. And f of 0 is 0 cubed minus 12 times 0, which is 0 minus 0, which is 0. F of 4, another endpoint function value, is 4 cubed minus 12 times 4, which is 64 minus 48, which is equal to 16. So you can see the 16 is absolute max, negative 16 is absolute min, so your answer will be A. Number 42. Locate the absolute extrema of f of x equal to x over x squared plus 1 on the interval negative 2 to 2. This is a rational function, and rational function is continuous as far as the denominator is not 0. But your denominator is never 0 since it is x squared plus 1. So this function is continuous on all real numbers. So it is continuous from the interval negative 2 to 2. And therefore, again, you will have both maximum and minimum by extreme value theorem. So let's find the derivative first to find the critical number. F prime of x then is equal to low x squared plus 1 d high, derivative of 2x is 2, minus high 2x times d low, derivative of denominator is 2x, over square below. So I'm going to square the quantity x squared plus 1. Now simplify, I get 2x squared plus 2 minus 4x squared over x squared plus 1 square, which is equal to negative 2x squared plus 2 over x squared plus 1 square, which is equal to, when you factor out negative 2, I get x squared minus 1 over x squared plus 1 square. So it factors as negative 2 times x plus 1 times x minus 1 over x squared plus 1 square. And this is never undefined. So does not exist, never happens. But it is 0 when numerator is 0, and numerator is 0 when x equal 1 or negative 1. So both 1 and negative 1 are critical numbers. And we are looking at interval negative 2 to 2, and both 1 and negative 1 are in the interval. So we are going to evaluate 4 function values. So first one, f of negative 2 is 2 times negative 2 over negative 2 squared plus 1. So I get negative 4 over 5. F of negative 1, one of the critical number, is 2 times negative 1 over negative 1 squared plus 1. So you get negative 2 over 2. which is -1. F of 1 is equal to, that's another critical number, 2 times 1 over 1 squared plus 1, which is 2 over 2. I get +1. Lastly, f of last endpoint, f of 2 is equal to 2 times 2 over 2 squared plus 1, which is 4 over 5. So which one is the largest value? Largest value is +1, which is the absolute maximum, and the smallest is -1, which is your absolute minimum. So the answer is E.